Good morning, dear students. My name is Ferhan Mazher, and today we are working on Cambridge O Levels Mathematics Syllabus D. We are working basically on the syllabus, and we have selected the topic of vectors. Uh, the, the session today, we are going to solve questions related with the expression of a vector in terms of two other vectors. We will also solve questions related with the position vectors, translation vectors. The book is New Syllabus Mathematics 7th edition, book 4, we call it D4. The soft copy which I'm going to use is of the Shinglee publishers, and the exercise I solved is from the Oxford University Press. In the Shinglee publishers, the D4 chapter 5 is about the vectors, and the Oxford University Press, the book of the New Syllabus Mathematics 7th edition, this is chapter number 7. So whatever book you have, if you have Shinglee publishers book, then it will be chapter 5. If you have Oxford University Press, then it will be chapter 7. The chapter is exactly the same, but only the numbering is different. So let's start today's work, and here we go. So we are talking about the exercise because the soft copy I have is this is of the Shinglee publishers. In this, the vector is chapter number 5 in the D4, and the exercise when I solved it, I used a hard copy of a book, and that book was of the Oxford University Press, and in that the D4's chapter 7 is about the vectors. The rest of the thing is exactly the same, only the chapter number is different in both the publishers' books. Okay, so exercise 7C, most probably in Pakistan, most of the people will have the Oxford University Press book. So the exercise is 7C in that book. Okay, so this is state which of the following pairs of the vectors are parallel to each other. The vectors, the column vectors are represented here. And you know this upper, in the column vector, the upper portion is, this portion is X and this is Y. This is X, this is Y. These are the two column vectors of a vector. And they want me to prove that they are parallel. They want me to know that prove that if they are parallel or they are not parallel. The method is very simple. You take the ratio of the x1 and x2, and you find the ratio of the y1 and y2. If both the ratios of the x1 and x2 and the y1 and y2 is same, the vectors are parallel to each other. So very simple. Question number 1, you can see here the two vectors are given, the column vectors are given. So the method will be very simple. So what I will do, this is the method which I'm going to use, x1, x2 ratio, minus 2 divided by minus 8, and that will be 1 by 4. And when I take the ratio of the y1 and the y2, it will be 1 by 4. So you can see the ratio of the x1 and the x2 and the ratio of the y1 and the y2 is same. So these two vectors are parallel to each other. Another way is if you multiply a vector, a column vector of a vector with a column matrix of a vector with a number, with a fraction, and you get exactly the second matrix, then they are parallel to each other. So this is also a method of doing this. Okay, so that was question number 1. It's A part. Okay, so we are going to the next question. B part, 9 and 18 and 7 and 21. So this is one vector. This is the other vector represented by the column matrix. Column vector, we also call it. So if the ratio of the x1 and the x2 and the ratio of the y1 and the y2 is same, they will be parallel to each other. Okay. So x1 by x2, that will be 9 by 18, and that will be 1 by 2. y1 by y2, that will be 7 by 21, and that will be 1 by 3. So you can see the ratio is not same, so they are not parallel. So these vectors are not parallel to each other. Okay, so here you have the C part. Here we have the column vector. So these two column vectors, they are representing two vectors. So this upper value is X, the lower value is Y. So we have to show that if they are, we have to find out if they are parallel or they are not parallel. So very simple, you just take the ratio of these two, you take these two vectors. Okay, so take the ratio of the x1 with the x2, and that will be 6 by minus 3, and that will be minus 2. Same way, take the ratio of the y1 with the y2. So that will be minus 8 by 4. That will be minus 2. You can see both the ratios are same. So these two vectors, they are parallel to each other. I hope you understand how you prove that the two vectors are parallel to each other. Okay, now we have question number 2 of the exercise 7C from the Oxford University Press book of New Syllabus Mathematics 7th edition, book 4. Question number 2. He says, write down two vectors that are parallel to each of the following vectors, one in the same direction, the one in the opposite direction. So if you want to write a vector which is parallel to this vector, simply multiply it with any number, If you multiply it with a positive number, the new column vector you get, that will be parallel to this. If you multiply it with a negative number, you will get a vector which is parallel to it, but in the opposite direction. So multiplied with a positive number, you get a vector which is parallel to it and in the same direction. You multiply it with a negative number, and then that will be a vector which is parallel but in opposite direction. So very simple. In my solutions, what I have done, I have multiplied it with the positive 2, so 16 and minus 14, and then I have multiplied that column vector with the minus 2. So I get minus 16, 14. So that this one is in the same direction and this is in the opposite direction. They are parallel to this vector. Okay, so the next one is B part. He says, this is the vector given. I want to find out a vector which is in the same direction. So I will multiply with the positive 2 and I will get 6 and 18. I will multiply with the negative 2 and then I will get minus 6 and minus 18. So this upper one is a parallel vector to this vector and in the same direction. This one is parallel to this vector but in opposite direction. I am multiply with the positive 2 and minus 2. You can multiply with any number. Okay, so the next one will be you see part, and you can see minus 6, minus 2. This is a vector, and they want me to write a vector which is parallel to this vector. So I will multiply it with the positive 2. I get minus 12, minus 4. That is a vector which is parallel to this vector and is in the same direction. I will multiply it with the minus 2, and I will get 12 and 4. And this vector is parallel to that vector, given vector, and is in the opposite direction. You see, the methodology is very simple. You multiply with a positive number, you get a vector which is parallel to the given vector. If you multiply with a negative number, you will get a vector which is parallel to the given vector, but in opposite direction. So this is how you will do this part. So that was question number 2, and I've done all of them. Okay, so we are going to the next question. The next question is question number 3. He says if P is equals to, it's a vector 5, 2. 5 means X and 2 means Y. And Q is 6 minus 3. The 6 is X and the minus 3 is Y. And R is minus 3 minus 4. Find a single column vector to represent the following. So the A part is P plus 2Q. So here in the place of the P, I will substitute this column vector. And in the place of Q, I will substitute this column vector. The method is very simple. You can see on your screen the 5, 2 plus 2 times 6 minus 3. This 2 will multiply with both the members here. So you will have 5, 2 plus 12 minus 6. 5 plus 12 will be 17 and 2 minus 6 will be minus 4. So this is the answer of P plus 2Q. Then the question is 3P minus 1 by 2Q. That's the B part. Okay. So in the B part, we will 3P minus 1 by 2Q. Simply put the value of the P and the value of the Q. So you will have 3 multiply with the 5, 2 minus 1 by 2, and in the square in the column vector you will have 6 minus 3. So it will be 15 and it will be 6 minus 6 divided by 2 will be 3, and I will not take this negative inside. Okay, I will keep it out. So 3 divided by 2 minus 3 divided by 2 will be minus 1.5. So it will be 15 minus 3 will be 12, and 6 minus 1.5. That will be 6 plus 1.5, and that will be 7.5. And this can be written as 12, and 7.5 can be written as 7 whole 1 by 2. So this is how you do the question number 3, and it's the B part. So the next question is question number 3. It's C part. It says 4p minus 3q plus r. So 4p minus 3q plus r. Okay, so simply you have to put the values and here we go. The C part is showing up on your screen. So simply substitute the value of the P, the value of the Q, and the value of the R in this expression. So 4 we multiply with 5, that will be 20. 4 multiplied 2 is 8. Then keep this negative outside. 3 multiplied 6 is 18. 3 multiplied minus 3 is minus 9. Plus, and you have minus 3 minus 4 here. So it will be 20 minus 18 minus 3. So it will be 2 minus 3 and it will be minus 1. 8 minus minus 9, that will be plus 9. 8 plus 9 is 17. 17 minus 4 is 13. So minus 1 and 13 is the answer. So this is how you will do this question number 3 and its C part. Hopefully you understand. Okay. So here we go. Write down the position vectors of the following points as a column vector. You see, if you know the coordinates of a point, the coordinates, for example, the point A, its coordinates are given to you. So you can write the position vector of A. The position vector of A is represented with OA, and the coordinates are written in the column vector. Okay. So for example, let me show you. For example, the A point is 4, 7. So OA will be, you take its coordinates, you write X, and then downstairs you write Y. So that is the column vector. This is called the position vector. If you know the position vector, it means you know the coordinates. If you know the coordinates, it means you know the position vector. So X is 4 and the Y is 7. 4, 7. In the same way, the point B is minus 2, 5. And so the position vector of the point B will be represented with the OB. From the origin, you join it with the B. That vector is called the position vector of the B. And that is, say the coordinates are the position vector. So simply you have to write them in the column vector form. And it will be minus 2, 5, like this in the column vector. Upstairs, you write X, and downstairs, you write the Y coordinate. So that is the question number 4 and its B part. Then we have C and the D part. Okay. So see in the C part, the coordinates are 6, minus 1. So that's the coordinates of the point C. The position vector of the point C will be OC. And that will be X, Y in the column vector. The X coordinate is 6 and the Y coordinate is minus 1. So this, 6 and minus 1, okay? So this is how you represent point D is minus 4, minus 9. So the position vector of the point D will be OD, and that will be XY in the column vector form. And the X coordinate is minus 4 and the Y coordinate is minus 9. So this will be the column vector of the, so it represents OD. If you join the origin with the point D, that will be the position vector of the D. Hopefully you understand, very simple and straightforward. Okay, so that was the question number 4. Now we are going to the next question. And the next question coming up on your screen is question number 5. If P, Q, and R are the vertices of the points, the P its coordinates are 3, minus 2, and the Q point is 2, minus 4, and the R point is 2, 3, respectively. Express the following as a column vector. So you have to find out P, Q. We know the coordinates of the P, we know the coordinates of the Q. We can find out the position vector of the P and Q as well. Okay. So the P is 3, minus 2. So the OP will be 3, minus 2. The point Q, its coordinates are 2 and minus 4. So the OQ will be 4 and minus 2 and minus 4. So if I know OP, I know OQ, the PQ I have to find out. Remember, this is called the position vector. So in the form of the position vectors, the PQ, remember this order OP plus PQ equals to OQ. P is at the start, so the OP will be here. The Q is at the end, so OQ will be on the other side of the equality. So when I make the PQ alone, and that will become OQ minus OP. Simply put the column vector of the Q, and that is 4 and minus 4, sorry, 2 and minus 4 minus, and the OQ will be 3 minus 2. So 2 minus 3 will be minus 1, minus 4 minus minus 2. It will be minus 4 plus 2, and that will be minus 2. So the PQ can be represented with the minus 1, minus 2. That's the column vector representing the vector PQ. And you have to, you can apply this formula. This is called the position vectors. Okay, so that is, then the next question they are asking is to find out the QR. The QR. So I will take both the Q and R. So QR, they are asking for the QR. The Q is 2 comma minus 4, R is 2 comma 3. So the OQ will be 2 and minus 4, and OR will be 2 and 3. So these are the position vectors of the Q and the position vector of the R. So their question is basically QR. They want you to find out QR. So the formula for the position vectors for the QR, because the Q is starting point, so the OQ will be written here. So OQ plus QR, R is the ending point, so equals to OR. So the QR will be equals to OR minus OP. Simply put the values there. So if you put the values, the OR is 2, 3, and the OQ is 2 and minus 4. So 2 minus 2, that will be 0, and 3 minus minus 4, that will be 3 plus 4, and that will be 7. So the QR will be, the column vector of the QR will be 0, 7. So hopefully you understand this. This is the use of the position vectors. Then we have to find out the value of the RP. Okay. So we know the position vectors of the, we know the coordinates of the R, they are 2 comma 3. We know the coordinates of the point P, they are 3 comma minus 2. So it means I know the value of the OR. That will be in the column vector form 2, 3. And the OP, which will be the position vector of the point P, that will be 3 minus 2. RP, because it's starting from the R, so its formula in the position vectors terms will be OR will be in the start, the P is at the end, so that will be equals to OP. So OR plus RP equals to OP. RP will be equals to OP minus OR. Simply put the position vector of the P and the position vector of the R there. So 3 minus 2 minus 2, 3. So 3 minus 2 is 1, and minus 2 minus 3 is minus 5. So the RP column vector will be 1 minus 5. The next question they are asking is PR. They want me to find out the value of the PR. So I know the coordinates of the point P. I also know the coordinates of the point R. So I can find out the coordinates. I can find out the coordinates easily of the you know, the point P is 3 comma minus 2, and the point R is 2 comma 3. The PR is question. If I know the coordinates of the point P, I know the position vector of the P, that is OP. That will be in the column vector form. It will be 3 minus 2. And I know the coordinates of the R, so it means I know the position vector of the R, that will be OR, that will be its coordinates 2, 3 in the column vector form. Upstairs you write X, and downstairs you write Y. So the formula for the PR, because the starting point in this vector is P, so OP will come at the start on the left side. So OP plus PR, because it ended at R, so it will be OP plus PR equals to OR. So when I will make the PR alone, that will be equals to OR minus OP. So PR will be equals to 2, 3 minus 3 minus 2. So 2 minus 3 is minus 1. 3 minus 2, 3 minus minus 2 will be 3 plus 2, and that will be 5. So the column vector of the PR will be minus 1 and 5. So this is how you will do the question number 5. It's 4 part. Okay, so we are done with question number 5. Hopefully you understand. Okay, he says state which of the following pairs of the vectors are parallel. Okay, if the two vectors, their column vectors are given and you want to find out if they are parallel or they are not parallel, the method is very simple. You take take the ratio of the x1 with the x2. You take the ratio of the y1 with the y2. If both the ratios are same, the vectors are parallel to each other. So let me show you. This is question number 6, A part. For example, here you can see this. These are the two vectors given. So I will take the x1 by x2. That will be 6 by minus 4, and the ratio is minus 3 by 2. I will take the ratio of the y1 with the y2, and that will be minus 3 divided by 2. So the ratio is minus 3 by 2. You can see both the ratios are same. The ratio of the x1 to the x2 and the ratio of the y1 to the y2. If both the ratios are same, the vectors are parallel. So these two vectors, which are given in the column vector forms, these two vectors, they are parallel to each other. So that was the question number 6. It's A part. Then we have the B part. These are the two vectors given. I just want to prove that they are okay. So I will take the ratio of the x1 to the x2, and I will take the ratio of the y1 to the y2. So that will be minus 5 by minus 3, and that is 5 by 3. Y1 by y2 will be 15 divided by 9. So cancel it with the 3. So you will have 5 by 3. So you can see both the ratios are same. So these two vectors, they are parallel to each other. Okay. So now the next question, question number 6, is C part. He says two vectors are given, and we have to show that if they are parallel or not. Okay. So how you will find out that they are parallel? You will find the ratio of the x1 to the x2. That will be 7 by 2. Okay. So y1 by y2, that will be minus 8 by minus 3. That's 8 by 3. So you can see the ratio of the x1 to the x2 and the ratio of the y1 to the y2. These two ratios are not equal to each other. So these two vectors, they are not parallel to each other. So this is a very simple, straightforward concept. Okay, so we are going to the next question. That's question number 7. He says, given that 5, 2, and 20p are parallel vectors, find the value of the p. Okay, if these two are vectors, he says that they are parallel. So if they are parallel, so what will happen? Okay, so that because they are parallel, so their x1 and the y1 ratio, the ratio of the x1 to the x2, x1 and x2 is equal, should be equals to the y1 and y2. And so it will be 5 by 20 equals to 2 by p, x1 by x2 equals to y1 by y2. So cross multiply. So 5p will be equals to 2 into 20. So p will be equals to 2 into 20 divided by 5. So that will be 40 divided by 5, and that will be 8. So the value of the p in this case is 8. Okay, so the next portion they are asking is, given that h and 12 plus and 3 and minus 3, 9 are parallel vectors, find the value of the h. Okay, so these two vectors, it is given that they are parallel. If these two vectors, they are parallel to each other, then the ratio of their x1 to x2 and the ratio of their y1 to y2, that ratio will be same. So x1 by x2, that will be h by 3, that will be equals to y1 by y2, that will be 12 by minus 9. So minus 9h is equals to 3 into 12. H will be equals to 3 into 12 divided by minus 9, and that will give you minus 4. So when you cross multiply it, so the h value is minus 4. So this is how you will find the value of the h. These two vectors, it was given that they are parallel. You don't have to prove they were parallel. So okay, so that is how you do question number 7. Okay, so we are going to the next question. The next question of this exercise is coming up, and that is question number 8. Okay, he says, for each of the following, find the values of x and of the y. Here, a vector is given who is xy, B vector is given, whose column vector is 3, 4. And then a relationship is given, equation is given, which is A plus 2B is equals to 8, 9. So we have to find out the value of the X and the Y. Method is very simple. You see question number 8, A plus 2B is equals to, in the column vector, we have 8, 9. So in the place of X, A, I will put this values XY plus 2 times 3, 4 equals to 8, 9. So it will be X plus 2, 3 is 6, X plus 6, and downstairs you will have Y plus 8, and that will be equals to 8, 9. So it means this and this is same, and this is same, same. That's why these two vectors are equal. So it means X plus 6 is equals to 8. So X will be equals to 8 minus 6. So X will be equals to 2. Y plus 8 will be equals to 9, and Y will be equals to 9 minus 8, and Y is equals to 1. So this is how you find the value of the X and Y. So U is equals to 2, Y, V is equals to X2, and the 4U plus V equals to 2. 4U plus V is equals to 2, and then a column vector 1 by 2 and 9. So I will, okay, so the B part is showing up. Okay, so U is equals to 2, and downstairs you have Y, X, and downstairs you have 2, that's V. So it is given that the 4U plus V is equals to 2, and column vector you have 1 by 2 and 9. So you will have 4, then you will have a column vector, the value of the U is 2 and Y. And then you have plus V value is X2 equals to 1 by, then this 2 will multiply with the 1 by 2. 2 will be cancelled. You will have 1. When the 2 will multiply with the 9, it will be 18. So here you will have 4 2s are 8 plus X, and downstairs you will have 4Y plus 2 equals to 1 by 18. This upstairs thing is equals to this thing. So I will write here 8 plus X is equals to 1. So X will be equals to 1 minus 8. So X will be equals to minus 7. In the same way, you will have 4Y plus 2 equals to 8, and 2, 4Y is equals to 18 minus 2. So 4Y is equals to 16. So Y will be equals to uh, Y will be equals to 16 by 4, and Y will be 4. So this is how you will find the value of the X and the Y. That's the B part. Question number, and this is question number, I think 8. Okay, question number 8, it's C part. He says P is equals to X5, Q is equals to 6, and Y. And it says 5P minus 2Q is equals to 323. So we'll put these values in this. Okay, so P is X5, Q is 6, Y. So he says 5P minus 2Q is equals to 323. Okay, so just substitute the value of the column vector P and the column vector of the Q. So you will have 5x 5, and then in here you have x5 minus 2, and here you have 6y, and equals to 323. So you will have 5x minus 12 upstairs, downstairs you will have 25 minus 2y. That's equals to 3 and 23. So 5x minus 12 is equals to 3. Compare the upstairs thing with the upstairs thing. And so 5x will be equals to 3 plus 12. So 5x will be equals to 15. So x will be equals to 15 divided by 5. And x will be equals to 3. Let me show you. In the same way, 25 minus 2y is equals to 23. So minus 21 minus 2y is equals to 23 minus 25. Minus 2y is equals to minus 2. And you will have y minus is cancelled. So you will have y equals to 2 by 2. And the y value will be 1. So this is how you will do the question number 8. And hopefully you can see the whole question is showing up on your screen. Question number 8. And it's C part. Okay. Okay, we are going to the next question. He says, illustrate each of the following on a sheet of squared paper or graph paper. So here the column vector A is the matrix A is represented with a column vector that's -1, 1. B is represented with 1, 2. The first question they're asking is to illustrate each of the following on a sheet of the square paper or graph paper. The first one they ask is 2A plus B. Okay. 2A plus B. Question number 9. Okay, so we are going to question number 9. So they ask us to represent 3A plus. Okay. So they are basically asked us to find out the value of the 2A plus B. The A and the B, both column vectors are known to us. So it will be 2 square column vector. In the column vector, we have -1, 1 plus, and the B value is 1 and 2. So it will be -2, 2 plus 1, 2. The x will be added in the x, the y will be added, subtracted in the y. So -2 plus 1, that will be -1, and 2 plus 2 will be 4. So this is how you do question number 9. It's A part. Okay, so we are going to, yeah, we also have to represent. This was the, okay. So now I'm going to show you how to represent this. You see, this is a graph paper. So the A is -1. Sorry, what is the A? -1, 1. Okay, so you can see 2A plus B. So I started from here. The A is, the A is what? The A is -1, 1. Okay. Okay. So I started from here, -1, 1. It means on the x-axis you move one step to -1, 1 means on the x-axis move one step negative. And on the y, 1 positive means go upstairs. So you have to represent 2A. So if I start from here, one step to the left, one step to the one step upward. This is 1A. One step to the left, one step upward. This is the second A. Join these 2 points. This is 2A. The B, the column vector for the B is what? 1, 2, 1, 2, 1, 2. So from the head of the first vector, I will put the tail of the last vector. 1, 2. So you go one step to the right and 2 steps upward. Okay. So this is the B, and you put the arrows like this. Join the tail of the first vector with the head of the last vector. So that will represent 2A plus B. The next question is B part. He says 3A plus 2B. 3A, 3A plus 2B. Okay, 3A plus 2B, there are two methods. One is you actually do this by the addition of the column vectors. So 3 and the A value is -1, 1, and the plus 2 into the B value is 1, 2. So it will be -3, 3, and it will be 2, 4. When you add the -3 with the 2, you get -1. And when you add 3 with the 4, you get 7. Okay. So I have drawn it here. You can see this. This is my starting point. One to the left, one to the one upward, one to the left, one upward, one to the left, one upward. That is the 3A. Then at the head of this first vector, I will make 2b. 1 to the right, 2 to the up. 1 to the right, 2 steps up. So that is 2b. Join the tail of the first vector from where you started with the head of the last vector. So that represents 3a plus 2b. Okay. Let me show you. So here we have a minus 2b. So this is a and this is b. A minus 2b, there are two methods. In one method, what you do, you take the column vector of a and b, and you do this process. So I will show you how this is done. Minus 1, 1, minus 2 times 1, 2. And so it will be minus 1, and we will not take the negative inside. We do not take the negative inside. And what we will do, and this is 2, minus 2, and when it multiply, only the positive number is gone inside. So it will be 2 and 4. This negative will remain here. Minus 1, minus 2, it will be minus 3. 1 minus 4, it will be minus 3. So this is done by direct addition of the column vectors. Okay, multiplication and addition of the column vectors. Now you have to represent this on a graph paper. So basically you want to represent a minus 2b. So the a is minus 1, 1. So this is one step to the left, one step upward. So this is, I started from here, and this is a, then I have to write 2b. And that will be 1 to the left and 2 steps down. 1 to the left and 2 steps down. So put a dot here. So that is the minus 2b. Then join the tail of the first with the head of the last. So it will be a minus 2b. So very simple. On the graph paper easily you can do this. Two, the D part is 2a minus 3b. 2a minus, okay, 2a minus 3b, just put those values of the column vectors there. So it will be 2, and in the bracket you will have minus 1, 1, minus 3, and in the column vector you have 1, 2. So it will be minus 2, 2, minus, and just take the 3 inside. Okay, it will be 3 and 6. Minus 2, minus 3, it will be minus 5. 2 minus 6, it will be 4. Rather, minus, it should be minus 4. Yeah. This should be minus, it should be a minus here, okay? Minus 4. Let's see. Do I? Okay, so question number 9 is D part. So I'm going to represent, here we have 2A. 2A means one step to the right, left, one step up, one step to the left, one step up. So join this point with this point, that is 2A. Then I have to represent the minus 3B. So that's one step to the left, two steps down, one to the left, two steps down, one to the left, two steps down. So join these, this is minus 3b. Then join the tail of the first with the head of the last, okay? So that will represent 2a minus 3b. 2a minus 3b, so very simple. Okay, so that was the D part. The next question is E part. He says 4a plus 3b. 4a plus 3b. So 4a plus 3b will be here. There are two methods. So directly we can do that by column vectors. Okay, 4 and minus 1, 1, and plus 3 and 1, 2. It will be minus 4, 4 plus 3, 6. And minus 4 plus 3, that will be minus 1. And 4 plus 6, that will be 10. Okay. So now I'm going to represent this on a graph paper, and how this can be done graphically. Okay. Okay. So you have to find out 4a plus 3b. So you can start from anywhere. So the 4a, so you can see the whole thing together. Okay. Now I will start from here at the bottom. One step to the left, one step up, one step to the left, one step up, one step to the left, one step up, one step to the left, one step up. That is, if you join the starting point with this point, it will be 4A. Then you have to represent 3B. So one to the right, two steps up, one to the right, two steps up, one to the right, two steps up. So that will be 3B. Okay. So join the tail of the first vector with the head of the last vector. That will be 4A plus 3B. So this is how you represent this on a graph paper. Okay, then we have the F part minus 3A plus 4B. Okay, minus 3A plus 4B. So it will be minus 3A plus 4B. So it will be minus 3. And then you have the column vector. You will have minus 1, 1 plus 4 into 1, 2. It will be, I will bring then this negative inside. I'll bring this negative inside. So it will become positive 3 and downstairs it will be a minus 3. Here you will have 4 and 8. So 3 plus 4 is 7. Minus 3 plus 8, that will be 5. Okay, so minus 3A plus 4B. So the minus A will be one step to the left, one step up, one step to the. So we are starting from here. So what is A? The A value is how much? Minus 1. Okay. So I have to represent minus 3 times A. Okay. So it will be one step to the right, one step down, one to the right, one step down, one to the right, one step down. So then from there, I will represent 4B. That is one step to the right, two steps up, one to the right, two steps up, one to the right, two steps up, one to the right, and two steps up. So that will be 4B. Then join the tail of the first vector with the head of the last vector. And that will represent minus 3A plus 4B. So this is how you will do the question number 9. Hopefully you understand. A little common sense is also needed for question number 9. Okay, the next question coming up on your screen. Here we have the diagram. Let me reduce the size. So the diagram below shows two non-parallel vectors, vector A and vector B. Using the squared grid below, express LM, PR, ST, and XY in terms of A and B. This question requires a lot of presence of mind. So you have to represent this LM in terms of this A and this B. You see, the A is you go one step to the right, two steps up. The B is you go three steps to the right, two steps down. So that is the column vectors of the A and the B. So the first one is we have to represent which one? LM. Okay, so I think I have, where's the LM? LM, I think I missed it. Okay, this one, LM. So I thought I missed the photo. Okay, so this is how you present the A, one step to the right, two steps up. This is B, three steps to the right and two steps down. And so what I will do, I will try to represent LM. Let me show you. So this is LM, which is given in the question. Okay, the LM is given in the question. It is 1, 2, 3, 4. 4 steps to the right, 2 steps up. Okay, so I have drawn that on the graph paper. 4 steps to the right, then 2 steps up. Now I have to represent the LM in terms of A and B. So from the A, I made a B from the tail of this LM. 1, 2, 3, 1, 2. So this is A, sorry, this is B. And then 1, 1, 2, 1, 1, 2. So this is 2A. You see, I started from the L and I reached the M by moving according in the pattern of B and A. So the LM will be equals to B plus 2A. LM will be equals to B plus 2A. This question requires a lot of, what you say, what I will say. It requires a lot of ready wit, presence of mind. Okay, the next part is PR. So they want me to represent PR. Okay, the PR. Here it is. Okay. So the A, this is A, 1 to the right, 2 steps up. B is 3 steps to the right, 2 steps down. And here is the PR. Okay, I have PR. You see, 1, 2, 3, 4. Sorry, 1, 2, 3, 3.5. You moved 3.5 steps to the right, and then you went 1, 2, 3, 4. You go 1, 2, 3, 4, 5. You went 5 steps down. Okay, 1, 2, 3, 3.5. 1, 2, 3, 4, 5, and you got R. Okay, now I have to represent this in the terms of B and A. So I started from the P, which is the tail of that vector PR, and I made my move 1, 2, 3, 1, 2. That's 1B. Then I moved 1.5 and to the right, and then 1 step down. That's the half of the B. So this is 3B by 2 or 1.5B. From here, I moved 1 to the left and 2 steps down. That's minus A. And I reached the point R. So that is what I wanted. So it means the PR is 3B by 2 minus A. You see, this is how you will represent the PR in the terms of A and B. Very tricky, not easy. Okay, then they want me to represent ST. ST is 1, 2, 3, 4, 5, 6, 7, 8. 8 steps to the right. Okay, so that is ST. Okay, now you can see the ST showing up on your screen. 8 step 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's a horizontal line, and I want to represent it in the terms of A and B. So I will start from here. So you can see 1, 2, 1, 1, 2. So this is 2A. Then 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So this was 1B. This is the other B. And I reached the T. So that's the end of that vector. So this is 2A plus 2B. Very tricky. Very tricky. ST will be equal to 2A plus 2B. Not that simple, okay? Okay, so the next thing is XY. This is the XY. Okay, so just start from the tail. 1, 2, 3. Not 1, 2, 3, 3.5. You move 3.5 to the X. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you went 9 steps up. That is XY. Okay, so I will okay, so we have to reduce the size a little bit. Okay. So you can count from here, and this is you can see that I have drawn the X and Y. 3.5 steps to the left and then 9 steps up. So that is XY. And I will start from the tail. So I moved 3 steps. How we can do that? Okay, let me show you. Okay, So I moved 1, 2, 3, 3.5, 2 steps up. 1, 2, 3, 2 steps up. Okay. So you moved 1, 2, 3, 2 steps up. That's minus B. 1, 2, 3, 2 steps up. That's minus B. So this is minus 2B. So this vector is minus 2B. Then 1, 1, 2. That's 1A. 1, 1, 2. That's 1A. Half and 1. That's half A. So 2A plus half A, that will be 2.5A, 2.5A. Okay. So that's 2, 5 by 2, 5 by 2A, 2.5A minus 2B. So this is a very tricky question. Okay, this is not simple, straightforward thing. Hopefully you understand, and let me show you that. This is how it is done. It's a little tricky. That was question number 10. Okay, we are on the question number 11. It says a point A, which is minus 3, 8, is translated by a translation vector AB on, and the column vector is minus 2, minus 4 to the point B. Find the coordinates of the point B. You remember that position vector formula that the position vector says OA plus AB is equals to OB. So OA is minus 3, 8, and the OA is the position vector of the A, which is given minus 3, 8, and the AB is minus 2, 4. And so minus 3 minus 2 equals to OB. So minus 3 minus 2, that will be minus 5. And 8 plus minus 4, that will be 4. So the column vector, the position vector of the B is OB, and that is equals to minus 5, 4. And so the coordinates of the point B will be minus 5, 4. This is how it is done. Or you can see, you plot on the grid the A and B point and check going from A to B, how much you moved on X and how much you moved on the Y. So on the X, I moved minus 2 steps. And it is given how much you have to move, minus 2 and 4. So move 2 steps to the left and 4 steps down. So minus 3 minus 2, it will be minus 5. 8 minus 4, it will be 4. So this is how it is done. Hopefully you understand. Translation matrix you will also learn in the topic of geometrical transformation. And here also. Okay, the question number 12 is showing up on your screen. He says, AB is 9 and minus 15. CD is 2 by 3 of the AB. Okay, so the ratio between the AB, 2 by 3 of the AB. Okay, express the CD as a column vector. Very simple. In the place of AB, just put this column vector, and you will be able to find out the CD. Okay, so let's go. Okay, so the AB is given to me here. The AB is given, that is 9 minus 15. That's the column vector of the AB. The CD is equal to 2 by 3 of the AB. That is given in the question. So the CD will be equal to 2 by 3. And in the place of the AB, I will substitute its column vector. That is 9 minus 15. So when the 2 by 3 will multiply with the 9, you will get 6. When 2 by 3 multiplies with minus 15, you get minus 10. So the CD will be in the column vector form, will be 6 minus 10. So that's the A part of that question. Then they want me to find out, given that A is the point minus 2, 7, find the coordinates of the point B. The AB value is given, the coordinates of the A is given, so the position vector of the A, OA is known to me. So I want to find out the coordinates of the B. Very simple. I will apply the formula of the position vectors. And here you go. So you can see A is minus 2, 7. So the position vector of the O will be OA, and that will be minus 2, 7. According to the position vector formula, OA plus AB will be equals to OB. So OA is minus 2, 7. AB is given in the question, that is 9 minus 15, and OB we want to find out. So minus 2 plus 9, that will be 7. 7 minus 15, it will be minus 8. So the coordinates, the position vector of the position vector OB, or the position vector of the B is 7 minus 8. So the coordinates of the B will be 7 comma minus 8. I hope you understand and you will never forget this arrangement of the position vectors. Okay, then they say, given that D is the point 8 comma minus 5, find the coordinates of the point C. Okay, now I know the CD column vector, the column vector of the CD. I know the coordinates of the D, so I can very easily find out the coordinates of the C. Okay, the point D, is coordinates are 8 comma minus 5. So its position vector will be 8 minus 5. According to the position vector formula, OC plus CD equals to OD. This is the key of this question. OC plus CD, key point. I mean, OC plus CD equals to OD. I want to find out OC, so OC will be equals to OD minus CD. I know the OD. OD is the position vector of the point D. So that will be 8 minus 5 minus CD is given in my second part. We found that. That is 6 minus 10. So 8 minus 6, that will be 2 minus 5 minus 10. That will be minus 5 plus 10. And that will be positive 5. So the AC is 2, 5. That's the column vector. So the coordinates of the point C are the same. It is 2, 5. So this is by using the position vectors, I can find out the coordinates of the point C. That will be 2, 5. So hopefully you can see that. And okay, so we are going to next part. So we are done with the question number 12. So we are going to the, okay. So we are going to the next question. The next question coming up on your screen is question number 13. Okay. Okay, from exercise 7C, in the Oxford University Press book, it is chapter 7, and in the Shinglee publisher's book, it is chapter 5. The questions are exactly same. Okay, if this is a column vector of a vector, this is a column vector of a vector, are two parallel vectors, explain. Because you know, if when the two vectors are parallel to each other, the ratio of the x1 to the x2 is equals to the ratio of the y1 to the y2. That is my explanation. So let's see. Okay, so these are the two vectors, and they say these two vectors, they are parallel to each other. So the ratio of the x1 to the x2 will be equals to the ratio of the y1 to the y2. So the A by C will be equals to the B by D. That is how this is. That is how this is done. Okay, so that was question number 13. So now we are going to next question. Question number 14. He says it is given that the vector u is the column vector is minus 5, minus 15, and 8. He says if u is if u equals to k times v, where the k is a positive constant and the magnitude of the v is 51, find the value of the k. Hence, find the value of the. First of all, I'll find the magnitude of the u. I will put that in this equation, the magnitude of the u and the magnitude of the v, and I will find out the value of the k. Once I know the value of the k, then I will use the same equation. I will put the value, the column vector of the u. I will put the value of the k, and I will find the column vector of the v. That's the strategy. Okay, so here we go. Oh, no, the diagram is not that. Okay, now it's better. So u is equals to minus 15, 8. So the the magnitude of the u will be, you remember, it is x square plus y square and square root on it. So it will be square of the minus 15 plus square of the 8 and square root on them. So it will be 225 plus 64 and square root on them, 289 square root on them. So it will be 17. So the magnitude of the u is 17. The magnitude of the v is given in the question, that's 51. this equation is given that U is equals to K times V. So U magnitude is 17 and equals to K, and the V magnitude is 51. So the K will be equals to 17 by 51, and the K will be 1 by 3. So the U will be 1 by 3V. And I want to find out the value of the, now I will use, once I know the value of the K, that's 1 by 3. Now I will use the same equation, U equals to 1 by 3, U equals to KV. The K value is 1 by 3, so U is equals to 1 by 3V. I will now use the column vector. The column vector of the U is minus 15, 8 equals to 1 by 3V. So V will be equals to 3 multiply that column vector. So when 3 will multiply with minus 15, it will be minus 45. When the 3 will multiply with the 8, it will be 24. So the column vector of the V will be minus 44, 5, and 24. So this is how this question is done. So okay, so we are going to the next question. The next question is question number 15 coming up on your screen. Okay. So the question number 15 is showing up on your screen. He says that given that the AB is minus 3.5, CD is 1.4, EF is equal to K 7.5, and the PQ is minus 1 by 4 and 1, express the 2AB plus 5CD as a column vector. Just have to put the values here. This A part is very simple. And here we go. Okay, so we are going to the next part. Okay, why is not moving? Okay, sorry, this was in the other file. Okay, now I have this. AB is this, CD is this, EF is this, PQ is this. The first part, they asked me to find out 2AB plus 5CD. So just in the place of the AB, substitute its column vector. So you will have 2 and the column vector is minus 3, 5 and 5, and the CD column vector is 1, 4. So it will be minus when this 2 will multiply with both of them. So it will become minus 6, and downstairs you will have 10. And when this 5 will multiply with this, it will be 5 and 20. So up the x will be added in the x. So it's minus 6 plus 5, that will be minus 1. 10 plus 20, that will be 30. So this is the answer of the A part. Okay, the next thing they ask us to do is find the value of the K if the EF is parallel to the AB. If those two columns vectors, they are parallel to each other, then their ratio of the x1 to the x2 and the ratio of the y1 to the y2 will be same. So here the x1 is k, here the x2 is minus 3. So k by minus 3 is equals to, here the y1 is 7.5, here the y2 is 5. 7.5 divided by 5. So k will be equals to 7.5 divided by 5, that is 1.5. So when you multiply it with the minus 3, you get minus 4.5. So the value of the k will be minus 4.5 because they said that these two vectors are parallel to each other. That's why we used this relationship that the ratio of the x's to the ratio of the y's will be same. Okay, so then it says explain why the PQ is parallel to the CD. Okay, that's the third part. Okay, so the third part. So why the PQ is parallel to the CD? You know the PQ is 1 by 4 and 1, and the CD is 1, 4. Okay, so find the ratio of the x1 to the x2. So it will be 1 by 4 by 1, that will be 1 by 4. Y1 by y2, that will be, here you have 1 and here you have 4. So it will be 1 by 4. So both these ratios are same. So the PQ is parallel to CD. Okay, so this is how you will prove that these two are parallel to each other. Very simple, straightforward. Okay, so next question coming up on your screen is question number 16. And he says in the question number 16, they say, L is the point minus 3, 2, and M is the point t comma 6. Express the LM as a column vector. So I can find the position vector of the L, that will be OL, and I will find the position vector of the M, that will be OM. And then I can find the LM, very simple, OL plus LM equals to OM. Okay, so this is the position vector. By the help of the position vector formula, I will find out. So OL will be minus 3, 2, and the OM will be T6. LM is question. According to the position vector formula, the OL plus LM equals to OM. So LM will be equals to OM minus OL, and LM is equals to, the OM is T6, and the OL is minus 3, 2. So it will be 2 minus minus 3, that will be T plus 3. 6 minus 2, that will be 4. So this is how you write that LM in terms of T. Okay. Then they want me to find out if LM is parallel to the vector P, which is 8, 1, find the value of the T. Okay, LM is parallel. Very simple. LM is T plus 3 and 4, and P is 8, 1. If these two vectors are parallel to each other, the ratio of their x1 to the x2 and the ratio of the y1 to the y2 will be same. So T plus 3 divided by I should have written T by 3. T plus 3 divided by 8 should be equals to 4 by 1. And I have already moved a step. So T plus 3 divided by 4 is equals to 8 by 1. So T plus 3 will be equals to 32, and T plus 3 will be equals to 32 minus 3. So T will be equals to 29. Here I have missed a step. There I have to write T plus 3 by 8 is equals to 4 by 1. Okay. So I missed one step, but the answer is right. There's no problem. Okay. Then they say if instead the length, the magnitude of the LM is equal to the magnitude of the P, find the two possible values of the T. Okay. Now they are talking about the magnitude. Okay. 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 If they are talking about the magnitude, so you can see here the LM magnitude is equals to the P magnitude. The magnitude of the LM will be T plus 3 whole square plus 4 square. Square root on it equals to 8 square plus 1 square. And square root on this. Square both the sides, so these squares will be gone. Square roots will be gone. These radical signs will be gone. So, I will have this thing. It will be T plus 3 whole square plus 16 equals to 64 plus 1. So it will be T plus 3 whole square equals to 65 minus 16. So T plus 3 whole square will be equals to 49. So T plus 3 whole square equals to 49. So take square root on both the sides. So you will have T plus 3 equals to plus minus 7. So there are two possibilities. It will be T plus 3 equals to positive 7. So T will be equal to 7 minus 3. That is T equals to 4. And the other possibility is T plus 3 equals to minus 7. So T will be equals to minus 7 minus 3. That T will be equals to minus 10. So these are the two possible values of the T. Hopefully you understand. Here they said that their magnitudes are same. Now the whole question is coming up, showing up on your screen. You can pause the video and you can take your time. Hopefully you understand. In the previous part, they said both the vectors are equal to each other, and here they're parallel to each other, sorry. And here they are saying their magnitude is equal to each other. So hopefully you understand this trick. We are done with the question number, I think, 16. So we are going to the next part. And that's probably the last question, I think, of this exercise. Yeah, that's question number 17. Let me reduce the size so you can see. In the question number 17, they say P is the point 2 comma minus 3, and the PQ is 8 minus 2 column vector. Find the coordinate. Very simple. I will write the position vector, the PQ, in terms of its position vectors. Okay. Okay, so the point P is 2 comma minus 3, and the PQ column vector is 8 minus 2. The point P is coordinates we know, so we can write the position vector of the P, that will be OP. So the OP plus the PQ will be equals to the OQ. That's how you write this in the terms of the position vectors. Because you started from the P, so the OP will come first. You ended at the Q, so the OQ will come on the on the right side of that equation. So the OP is 2 minus 3, and the PQ is 8 minus 2. The OQ is question. So 2 plus 8 is 10, minus 3 minus 2 is minus 5. So the OQ will be 10 minus 5. So the coordinates of the cube will be 10 comma minus 5. So this is how you find the coordinates of the point q. Then they say express pq. The vector pq is xy. Express the gradient of the pq in terms of xy. So this is the x, this is the y. The gradient is y divided by x. Very simple. It's a one-step question. Okay, the gradient of the PQ will be y divided by x. So if the PQ is this, the y will be minus 2 and the x is 8. So the gradient of the PQ line is minus 1 by 4. Then they say if the gradient of the PQ is y by x, express the PQ in terms of x and y. Okay, if I know the gradient of the PQ will be xy, the gradient of the PQ is y by x, the gradient of the PQ, if the gradient of the PQ is y by x, then what will be the PQ? The x will be written here, y will be written here, because it's possible that a certain number has been cancelled from when you wrote it in the fraction. So let me say that is k, so it will be kx, ky. So the PQ will be, you can take the k common, and this is how you will find this. And let me show you. This is the whole part is showing up on the screen. So simply a conceptual question. Okay, not a big deal. So my dear students, we are done with the exercise 7C. So my dear students, today we have completed the exercise 7C from the book D4 of the New Syllabus Mathematics 7th edition, Oxford University Press, the publisher. And this is Cambridge O Levels Mathematics Syllabus D syllabus. My name is Ferhan Mazher, and I hope that you will understand this exercise. If you find this exercise useful, if you find this video useful to you, please share the link of this video onto your Facebook account, onto your Twitter account, onto your Instagram. Share the link of this video with your class fellows, with your junior students, and with your teachers. It's a great blessing for me that I can do this. I can teach people through this YouTube channel. It's a blessing. Thank you very much, everyone. Have a good day. God bless you all.